So this workshop will be divided into 4 different stages. The first one is an introduction of the importance of data visualization framed in a science communication program. I will then explain the theoretical and practical principles that will make your visual effective, meaningful, and insightful. Later, I will introduce some key concepts pertaining to the elements we must consider while creating a visualization. And I will be finishing by providing some resources and advice for a potential career in this amazing field, or to how to make the next steps in terms of, okay, how do I communicate visually what I'm doing? I will now share a link to a document that has many of the visualizations we will be discussing today. I provided the links to the visuals that are cited in purple in the presentation, as well as plenty of resources such as blog posts and contacts of specialists in the field. At the end of the document, you will find a link to a Google form to gather extra feedback of this content and my performance. So please, I encourage you to complete it. It will take you just 2 minutes, and of course, your opinion is extremely appreciated. All right, so data visualization can be defined as the process of graphically displaying scientific data that serves as an interface between people and data. It can also be understood as a continuum between science and art. Where we position ourselves will depend on our communication objectives and our target audience. Sometimes we want our audience to perceive the absolute values data more accurately, establishing comparisons and make better decisions. Other times we may want to be closer to the art side of the spectrum with the goal of engaging and exciting our audiences, even if they do not permit the most accurate comparisons. So our decisions of which graph to use, where we place labels and annotations, which colors and fonts to use, and how we lay out our visualizations are mostly subjective. The secret here is to practice, explore, get feedback, improve, and keep practicing. As you create more and more visualizations and read more graphs, you will develop your own eye and aesthetic and your own balance of art and science. John Medina, a developmental molecular biologist, in his 2008 best-selling book, Brain Rules, states, the more visual the input becomes, the more likely it is to become recognized and recalled. The more visual we can make our data and content, the more we can expect our readers to remember it and hopefully use it. So reading a graph involves a more complex cognitive process than reading a paragraph, right? So we have the difference between visual information and textual information. And you need to understand that the boring graphs are extremely forgettable. For example, this graphic from an interactive visualization from the OECD enables users to explore the different metrics and definitions of what it means to have a better life. A more standard chart type, like a bar chart, might enable easier comparisons, but would it be as much fun as this? Here, we can also compare specific countries, such as where you are, the United States, and where I am right now, Germany, and their metrics. So you will have here, as you can see, this is a purple link. So you will have an access on the shared document to that actual graph. So you can actually play around with the different displays that this graph has. The quality of information used, that it needs to be, of course, relevant, factual, and accurate, must precede the quality and visual appeal of the visuals themselves. That is a really, really important take-home message that I want you to have. Laszlo Moholy-Nagy, Hungarian painter, photographer, and professor in the Bauhaus School, once said, "Designing is not a profession, but an attitude." We're all designers since we have an impulse for organizing matter and ideas into objects and patterns. I will introduce now some key concepts that we will use throughout this workshop. So visualization or data visualization is any kind of visual representation of information designed to enable communication, analysis, discovery, and exploration, among other actions. They are often conceived as tools for the audience to extract their own conclusions from the data. And you need to remember that every visualization is a model. A chart is a display in which data are encoded with symbols that have different shapes, colors, representations, or proportions. And this is something that you are really familiarized with when you look at the map, when you look like a subway pattern, for example, here at the city of New York. Also, an infographic is a multi-section visual representation of information that is intended to communicate one or more specific messages. Lastly, a map is a depiction of a geographical area or a representation of data that pertains to that data. So I want to introduce some of the theories that are behind how we organize and visualize data. So in order to do that, Gestalt theory is extremely relevant for this. So Gestalt theory was developed by German psychologists in the early part of the 20th century, and it refers to how humans tend to organize visual elements into groups. Even though these principles are more than 100 years old, many of their core ideas persist in many disciplines, including information theory, vision science, and cognitive neuroscience. So the first one, the concept of proximity, is the perception of objects that are close to one another as belonging to a group. For example, we might have labels with data points, bars with each other, or clusters of points in a scatter plot, such as in this case. Our brains group objects that share the same color, shape, or direction. For example, adding color to this scatter plot reinforces these two different groups. At the same time, enclosure is bounding objects that are perceived as a group. So in addition to use color, we can enclose the two groups with circles or other shapes. So here we are adding more and more complexity in terms of how to visually represent this specific idea. Also, for example, we have the concept of closure, which is that our brains tend to ignore the gaps and complete structure with open areas. For example, in the line graph, we mentally close the gap between the two segments in a straight line, even though the missing data might yield a pattern that moves up and then down, right? For example, the concept of continuity is when objects are aligned together or continue one another that are perceived as a group. So in this case, for example, you don't need the horizontal axis line in this bar chart because the bars are aligned along a consistent path between the labels and the bottoms of the bars. Also, the concept of connection is when we perceive connected objects as members of the same group. So for example, take this series of dots. At first, we are perceiving, as a single series, a mass of blue dots. So for example, adding color makes it clear they're the two different series. And furthermore, connecting these dots make it clear how they initially track each other, but then diverge into this specific map. Deeply related to Gestalt theory is the concept of reattentive processing, which is a subset of the Gestalt theory. And here is extremely relevant when creating data visualization, and is something that I always use when I conceive the ideas and when plot this into specific charts. So as we have seen, because our eyes can detect a limited set of visual characteristics, we can combine various features of an object and unconsciously perceive them as a single image. Pre-attentive attributes such as shape, line width, color, position, length, and more draw our attention to a specific part of our image, or in our case, a graph. So here is a list of examples of pre-attentive attributes we can use in our visualizations. Now we are going to move to the second stage of this workshop, which is basically the principles that are behind great, impactful, engaging visual pieces, right? So I kind of intended to summarize what the recent literature is saying in terms of the qualities that all great, engaging visualizations should possess. The first one is actually common across every communication, science discipline, and it's actually being truthful, right? So based on thorough and honest research, the data that you conceive, it needs to be based on research that is sounded and honest. So we need to present information concisely, simply, clearly, and elegantly. Nevertheless, you need to understand that truth and untruth are two extremes of a spectrum rather than absolute concepts. So In terms of being truthful, according to the literature, it is involving actually two different strategies. On one hand is avoiding self-deception, which is, for example, truthful graphics that are created by people who do their best to prevail over the intellectual shortcomings and ideological biases by applying certain critical thinking techniques, and we will see some examples later on. And the second strategy to being truthful involves being honest with your audience. You need to convey to them and show them your best understanding of what the reality is, right? So the first thing that we need to actually take into consideration is showing the data. So your reader can only grasp your point, your argument, or your story if they see the data, right? So it doesn't mean that all the data must be shown, but it does mean that you should highlight the values that are important to your argument. As content creators, our challenge is deciding how much data to show and the best way to doing so. So for example, in this case, highlighting a few countries in the chart on the right makes it easier to read, right? So in the graph, just 6 countries of interest are highlighted while the remaining are set in gray, and they're blending into a neutral background, right? It is way better than the one in the left. So the second point that I want to make in terms of being truthful is actually knowing your audience, and that is something that is a very strong signature across all different courses in science communication, in particular at the Alda Center, right? So as early as possible in the design process, we need to identify the audience and the message that the visual is actually conveying. So for example, we have here the results of the first round of the presidential election in France from 2 weeks ago, right? So now we have the last results passed this weekend, and Macron is going to be is going to continue in his seat. So here in this map, you can clearly see the heterogeneous distribution of the votes throughout the country. But what is actually that informing us in the United States? And for example, I want to make this honest question to all of you, like, what do you think about this graph and how can it be improved in the sense of knowing your audience? Because I'm telling you a story related to France election to an audience that is not part of that country. So I would love to know your honest opinion about that and why I purposely did this to actually test this with you live.
So if I was to go ahead, my glance at this would tell me that these are population centers that are brightly lit. So there's a high density of people there. But I am unfamiliar with the French system but I am going to assume that the areas demarcated in green in white are districts, but in order to actually win the vote, you just, as far as I understand, you needed to win the total population vote. So because the vote was total, this graph doesn't immediately tell me who won, because someone in one of those bright spots, there could be an enormous population density in one of the bright spots that I can't track.
And for example, where are the numbers here, right? I don't see any number, right? And for example, for someone that is not familiar with European politics or with French politics in particular, you know, like who is Marine Le Pen? We don't know. So for example, in my case, I would, choose to put a photo of the candidates and a little bit of information about the political party. In this case, it's extremely important because Marine Le Pen is a representative of the far right political movement in France, which a potential victory of her would, have really drastic consequences for the future of France and the European Union. Any other thoughts on how can this graph can be improved in the sense of knowing your audience?
Maybe so just a label of those population centers. I mean, clearly that area where there's a lot of orange is Paris,
is Paris,
right. So there's Macron, and it doesn't look like Le Pen was very popular in that area, but was in probably more rural areas, I'm guessing. Just some labels of just the key spots would be good.
Exactly. So as you can see, and just for me to make the point is that I am presenting this to an audience that is not French, and I would I am imagining that, there is not so much background about, the present politics of this country. So I did this in purpose in terms of, triggering a discussion in terms of how effective this map would be for different audiences. All right. So moving on, another last point that I want to make in terms of being truthful is actually being really clear to establish the role and the communicational objectives of your own specific visual. So in this case, you can clearly see the objective of this infographic regarding how to better convey a lot of information related to rubella in an accessible, easy way, right? This is, of course, a really highly professional visualization by the Lancet, and these people that are specializing to conveying this really highly complex medical information into the general audience. So the second aspect of a great visualization is actually being functional, and I'm going to be conveying a lot of information here because I think it's a fundamental thing, and many people are actually missing the point here. So being functional basically means considering an accurate depiction of the data. So here the goal is to help your audience to interpret the information correctly. And that is a really big responsibility that we as data communicators, we need to do. So the objective of our visualization should somehow guide your decision of how to shape that information. So let's start with the basic, right? So we need to adapt the figure to support the medium. We know that each media represents different physical sizes and ways of viewing and interacting with the figure. It is not the same as a static figure it's very different from an interactive figure, which is different of a figure that is accessed via, social media, and also a figure that is actually printed in paper, right? So we need to be aware of that. The other thing is something that is so important is basically reducing the clutter, right? So unnecessary visual elements distract your reader from the central data and clutter the page. Simplifying the graph by discarding these, extraneous distracting elements and showing the data makes your argument clear and comprehensible. So for example, these 3D charts are distracting, hard to read, and distort the data. As a response, the basic bar chart eliminates the clutter and the distortion caused by the 3D effect, so the graph is easier to understand. And we can clearly see the difference here between, for example, the United States and the country I am right now, Germany, in terms of how scholarly has developed throughout time. Another thing which is extremely related to reducing the clutter is actually avoiding the chart junk. This is a concept, chart chunk, that is from the literature, is actually meaning to avert the unnecessary or confusing visual elements to do that do not improve the message in the best case, or add confusion in the worst case. So as we see in the example, displaying all of your data is unnecessary, it's chaotic, and it's also hurtful. As a response, you can choose to display all of the 7 series, for example, following the same example as before, but in isolation and in a scale of grace and on the same visual space to allow, for visually pleasing comparisons, right? So there's a highly contrasting differences here. The other point that I want to make is that text and annotations can be used to explain how to read the content in the graph, as well as how to read the graph itself, right? There are three ways we can integrate our graphs and our visuals, and they are basically removing the legends, creating active titles, and adding detail, which are all things that I'm going to be showing you in the next few minutes. So here we can clearly see the elegant, detail-oriented approach that Michaela used to visualize which are the bird species that are endangered in Italy and in which proportions. And perhaps many of you don't know any Italian whatsoever, but you can actually clearly see the differences, the striking difference between different species and how these species are organized in this visual. So here we have a powerful combination of phylogenetic relatedness data, a great use of a color palette, and impressive data accuracy. So the work by Lazzaroni is one of my favorite. It is very, very good. Another thing is that by integrating the text and the data, we're doing a better job of considering the reader's needs, right? And this is extremely important. So, for example, notice here the inconsistency between the orders of the lines and the legend of the chart on the left. The redesigned version on the right removes that unnecessary clutter and directly labels the lines. And that is actually very, very important and avoids all that confusion. In some cases, removing the legend is not always possible, and a bar chart with several categories or a map with different colors, for example, requires a legend because directly labeling the data on the chart will add too much clutter, right? So in these cases, at least keep the order of the legend consistent with the order of the data, and also the colors needs to be the same. Another thing that is also extremely important is the text that is joining that visual representation of data. And it is very important that we should treat a graph's title as carefully as the graph itself. So for example, active titles or headline titles better capture the takeaway of a chart, telling the reader what conclusions can be drawn from the data. Additionally, you can use Twitter-like headlines that are like really short sentences and very straight to the point. So integrating your graphs as part of your argument is actually creating a more cohesive approach to making your argument and telling your story. So in this case, the active title in this chart from the Pew Research Center is telling you exactly what you're supposed to learn from it. In this case, labor force participation rate has risen for women and fallen for men. Sometimes data sets have peaks or valleys or outliers or variations that bear explanation. And adding detail to graphs can push your argument and highlight your points of interest, or in case of non-standard graphics, actually even explain how to read them. So annotations allow readers, especially those who might have less experience with data visualization, to grasp and understand the content quickly. So in this case, for example, short explainers in this graph explain some of the basic features of the data and really highlights specific points that the author is claiming in its argument. Also, options explain how to read the figure and provide additional precision for what cannot be graphically represented. And this is also and always a very important ally for our visualizations. So for example, if numerical values are important, they must be provided or be written unambiguously on the figure. Similarly, if there is a point of interest, it must be visually distinguishable or highlighted in the captions. So for example, this amazing graph from Los Angeles Times uses annotations to explain how to read a graph and its content. Third quality of great visualizations is actually being beautiful. So striving to be attractive, intriguing, and aesthetically pleasing for your intended audience. So what matters here is not if the octets of your creations are beautiful or not per se, but if they are experienced as beautiful by as many people as possible. In this sense, color needs to be used extremely effectively. And in this case, color maps can be classified into qualitative, which is a rapid variation of colors used mainly for discrete or categorical data, as we can see on the graph on the left. Moving to the center, we can also have a diverging color map, which is a variation from one color to another, used to highlight a deviation from a median value, for example. And lastly, on the right, we have a sequential, which is a one variation of a unique color used for quantitative data varying from low to high. So we need to actually choose wisely according to your message and communication objective, what are the colors that we're going to be using. And there's plenty of resources and recent literature in terms of inclusivity and your data being accessible for color-blinded people, for example. And this is something that we always need to take into consideration. Additionally, of course, using color needs to be effectively, but it is also great advice to start with gray, right? When you make a graph, start with an all gray data elements, and by doing so, you force yourself to be really purposeful and strategic in using your colors, your labels, and other elements of your graph. It's obvious when a certain graph contains too much information. For example, line charts that look like spaghetti, like maps with dozens of colors and icons, or bar after bar littering a chart. For example, in this graph from Zeit Online shows the average temperature of Germany over the past 140 years. So as you can see, there's such a huge amount of data, and there's no way to interpret this as easily and accessible as we can. For example, one way to address the packed single chart is to break into smaller units, smaller parts. This is known as grid charts or panel charts. And actually, these are smaller charts that use the same scale, axis, and scope, but spread the data across multiple visuals, multiple charts. So in other words, instead of putting all the data on one graph, you're creating multiple smaller versions with variations on the basic data. So here we have multiple scatter plots from The Guardian, which shows the relationship between voting choice and 6 demographic variables. So, for example, it's really interesting to notice how the Gestalt principle of similarity is actually let us easily seeing the 2 clusters of circles within each scatter plot, which is something that is really important and very striking visually and very useful for our argument. The fourth component of a great visualization is actually being insightful, and this is extremely interesting and I'm very curious to know your opinion about this on the examples that we're going to see, at the end of this workshop. So, as you know, the purpose of visualization is to clear the path to making valuable discoveries that would be inaccessible if the information were presented in a different way. So, in that sense, you're presenting a unique perspective, a unique contribution with your visuals. In this sense, for example, there is this wonderful graphic by Periscopic for Scientific American magazine that you have the link on the shared document, which is actually regarding the gender gaps in PhDs across different countries. So in addition, another qualities of being insightful is to not mislead the reader. So a scientific figure is by definition tied to the data. And if you loosen this tie with the data, you might unintentionally project a different message than intended. And that might happen, and that is actually very dangerous sometimes, as we have seen with, for example, the behavior of people regarding vaccines for the coronavirus, or how different variants of the virus, specifically in the 2021 and 2022, have, sense different sorts of consequence in the people of seeing that data. And the last part, and is very, very important, is actually one of the really interesting components of our work as communicators actually is being enlightening. So if we grasp and accept the evidence it depicts, it will change our understanding for the better of a particular topic. So great visualizations give people access to the information they need to increase their well-being, hopefully. And choosing topics ethically and wisely, casting light on relevant issues matters, and matters a lot. So for example, let's take this Child Lives by the Pulitzer Center. Is actually a very interesting interactive graph that you also have access to that. So here we have a clear, striking visual that illustrates where mortality in infancy and childhood occurs globally. This is a hard but meaningful topic which needs to be addressed and communicated. So the point is that message always needs to win over beauty. It should always be like that. So in science, your message and the readability of the figure are the most important aspects, while beauty is only an option, right? So the most important things are the message and how that information, that message is being read, rather than how beautiful actually the visual is. So now we're going to be moving to the third part of this workshop, which is related to how to start in terms of making a visual, how to better understand your data set, and how to go from point A to point B in terms of having a data set, to having results, to having a visual, right? So to understand all this first, we need to actually set some background information and some really key important concepts, such as data. So the word data originates from the plural of the Latin word datum, which means something given, where something stands for a piece of information. And that piece of information can be anything from a numerical fact to a person or a quantity. So data here, and I will be using this definition in the plural term, refers to a collection of observed and measured phenomena. So as most of you might know, there are two major groupings of data types, and we have quantitative and qualitative. So on one hand, qualitative data is a non-numerical information, Essentially, it's usually descriptive, like in text, just as, for example, yes or no, or satisfied, dissatisfied, or longer quotes or passages from interviews and surveys. On the other hand, we have quantitative data. It's everything that can be measured with numbers, for example, distance, dollars, speed, and time. So we can further break down each major data type into subcategories. On the qualitative side, we have nominal and ordinal scales. Nominal are used to label variables and don't have an order or quantitative value. Also in ordinal scales, the order does matter, but the exact size in comparison between values is unknown. On the other realm, on the qualitative side, data can be either discrete or continuous, and that is very important in terms of how we visualize numerical data. So on one hand, discrete data are whole numbers, that are integers that cannot be subdivided. Continuous data, for instance, are numbers that can be broken down into smaller units such as weight, height, and temperature. And finally, continuous data can be even further subdivided into two major scales, interval and ratio. And that is also very, very significant in terms of how we diagnose our data set and how we can actually start designing our visual. So the difference is what we can and cannot calculate. With the interval scales, we know both the order and the exact differences, but we don't have a true zero value. For example, degrees in Fahrenheit. Ratio scales have all the characteristics of all the other scales, plus we have here an absolute zero, which means we can do all of our mathematical calculations. So this is a little bit technical, but it's something extremely important for you to understand where your data set is laying between, which specific type of data, and that is going to be a really important effect on the types of graphs that we will be using. And in that sense, I created this sort of schematic of how different data visualizations types can help us think through what kind of visualization is best for our audience, for our message, and for our communication objective. So we have a space that has two perpendicular lines. The vertical one is a spectrum of the general form of the visualization and runs from static to interactive. Static visualizations provide all the information at once and do not move. Here we have, for example, your basic line bar pie charts, right? Interactive visualizations allow a transfer of information between the user and the interface in a more dynamic way. So in this case, the user clicks and swipes and hovers, and something happens or additional information is made visible. On the horizontal spectrum is a function of the visualization. And here the visuals run from exploratory to explanatory. Exploratory visualizations encourage the user to explore the data or subject matter to uncover findings for themselves, right? And explanatory is bringing the results to the forefront. They convey the author's hypothesis or argument to the reader. This is something that is going to be extremely useful for you to actually position yourself in terms of what is the best way to actually convey your visual data. So here, the intersection results in 4 quadrants. We have interactive exploratory, interactive explanatory, static exploratory, and static explanatory. Let me dive deeper into these 4 categories. The static exploratory visualizations let readers interpret the data and find their own results and conclusions in a static display of information. This is sometimes extremely easy to do and is very powerful in terms of transmitting your information. On the other hand, we have static explanatory visualizations that are typically used to illustrate a point or reinforce an argument made in a text or presentation. On the other hand, we have interactive exploratory visualizations that graphically present a complete data set and ask users to find interesting patterns on story and actually play around with the data and play around with the type of information that you can get and the type of conclusions that you can extract. So for example, through text, video interviews, static and animated visualization, this wonderful piece by The Guardian in 2018, Bust Out, tells a story of how US city governments bus homeless people out of their city. So please take a couple of minutes to go through this visualization because it's actually absolutely amazing the way how they display data and how they tell story. And finally, in interactive explanatory visualizations, we can engage a reader to experience a story or explain a process. These paths to the White House, I know it's a little bit outdated, but it's a really good example of this by the New York Times. It's a graphic that lets the user to pick the different paths by which either presidential candidate could win an election. And finally, we're diving into the last segment of my workshop, which is related to actually the effect that our visualizations have in your audience, how to best interact with that. And the best way to actually start this topic is something extremely relevant, and there's a lot of literature and a lot of discussion around this topic, is data equity and responsibility. So whenever we work with data, it's really, really important to recognize that visual content can have a really large influence on how people use data and make decisions. And a really clear example of that was how people extracted information from those initial infographics and visuals at the beginning of the pandemic back in 2020, right? Think about those things. So this is extremely important, and as data communicators, it is our responsibility to treat our work and our data as carefully and objectively as possible. It is also a responsibility to identify where our data might suffer from underlying bias or error, or even implicit bias that data creators may themselves not even be aware of. And this is a really clear textbook example of the redlining map of Richmond, Virginia back at the beginning of the 20th century, which is actually demonstrating, and this is very shocking, how data and data visualizations can be wielded to further systematic discrimination. So for example, information studies scholar Safia Omoja-Noble is arguing that modern internet search engines and other algorithms are actually enacting new ways of discrimination and racial profiling, creating a modern form of technological redlining. So this is a really clear red flag that I want to put to you, to the audience, to actually start thinking those things in terms of implicit and explicit bias, and how our visualization are actually affecting how people are interacting with that data. And we don't need to go back to 100 years ago to actually see this in action, because as Omoja-Noble is actually saying right now, there are new ways, for example, in social media and racial profiling, and also even artificial intelligence, different algorithms of AI that is actually keeping that bias that we humans by definition have in something that is completely random and artificial as well. So that is something that it is a really important topic for me to actually bring to the table and to discuss. So in that sense, let me introduce a great recent example on how data visualization can steer different interpretations of the reality. And that is something really, really important and very interesting, and that happens extremely recently. It's really interesting to see how the New York Times graphics has changed their map representation as the Russian invasion of Ukraine unfolded. So here we have on February 26, large red arrows and an almost opaque red color shows that is showing Russian advances in Ukraine, suggesting fast, large, and controlled overtaking. A few days later, on March 3rd, the arrows are considerably smaller and the occupied areas are shown in a more transparent red color, suggesting a complexity in the reality on the ground. Still, Ukrainian forces appear non-existent on the map. 4 days later, on March 7th, the New York Times map now show for the very first time the Ukrainian forces in blue. Russian forces are giving a slightly more pink tone. Now occupied areas are rendered with a more transparency than before, but cities under Russian control are now labeled in red. On March 21st, almost a month into the Russian invasion, Ukraine's presence in the map is increased by showing all large cities under Ukrainian control in blue, and the Russian occupied areas previously shown in red are no longer shown on the map. So we have a striking difference from a couple of weeks before the initial maps to the more recent one at the end of March. So I'm very curious to debate here about how much of these changes in visualization are simply due to strong Ukrainian forces, or because there is an increased recognition that different cartographies can significantly change how one understands the war. So in this sense, I would love to ask all of you, what do you think about this? And if you think that the data have been truthfully represented, and how might we represent the data in a better way? I don't know if you captured the last part.
I think it's really interesting to see the developments of how they're representing it. I tend to think that it probably has more to do with the New York Times trying to represent it more accurately, possibly due to feedback. I'm not sure, but yeah, I'd have to think about how to better represent it, do a better job with what they're already doing. That would be. I think it would be interesting to also see where populations are, right? Where there might be civilian populations or that sort of thing. So
yeah, anybody else have some thoughts and some insights?
I like your point about how the cartographer had it is within the cartographer's hand to create a story, because at the beginning of the incident of the war, it was assumed that Russia would steamroll Ukraine by a lot of people, and or at least people in the mainstream media, and that particular map shows a similar thing. And later on, as you said, there's much more nuance there, because the world has more nuance, and the New York Times was forced to, I suppose, understand and explain to us this nuance that was surprise to them.
So as you can see, we have like top-notch multimedia elaborating visuals, but from our humble point of view, we can actually increase our understanding and playing out different edits and different multiple perspectives into something as important as how the invasion of a powerful country to another country is laying out in real time. So I think that example is a very useful one and very recent, and something that we can further analyze and reanalyze over the next months. So the second example that I want to bring to the table is that in the wake of Russia's invasion, millions of refugees are fleeing Ukraine. So support for these refugees is currently very high, right? So for example, recent polls have found residents of other European countries overwhelmingly support taking in Ukrainian refugees. For example, 90% here in Germany. So I'm currently actually seeing that in something very, very striking for me. I have met here in Düsseldorf, in the city that I'm living, more than a dozen of Ukrainians in the last month only. And there is something that you can see in the street. You can see also in the research institute that I'm working, they're hiring multiple Ukrainians every week. And that is something very, very striking. So now related to how we actually visualize real time and in real time people moving from different countries. It is also very striking for me that this level of support is very different from the last sudden influx of refugees in Europe back in 2015, when 1.3 million people from several Middle Eastern and African countries sought asylum in Europe, many fleeing the Syrian civil war. So in that instance, public support for refugees was really much lower, especially in countries that historically are dealing with this very sensitive topics, such as Germany or Poland, for example. So in the US, 74% of Americans as of last month are saying that they support accepting Ukrainian refugees, although Americans have long been reluctant to accept refugees from various international conflicts, especially the ones related to Central America and Mexico. So for example, now that we see this,
I would add Haiti. Haiti is a stark example.
Exactly. Yeah. Central America, the Caribbean, and Mexico. For example, now that we see the data, right? So we see different variables, different colors. It's a really beautiful descriptive visual by a colleague, Laura Bronner, from 538. It's something that David has mentioned before. So for example, how would you better visualize this data? Like I'm throwing this question to you guys. And do you think that there are any other variables that can be included in this type of analysis? So what do you guys think? For example, in this case, I was also thinking on, plotting the difference according to different countries, which is something that we don't have that data as of right now. And other thing that I was thinking is what happened before and after 2022, right? So kind of like comparing what is the acceptance rate of refugees in different countries, but also across a different time scale, right? So that is also a really clear example of how data is being visualized in a different way. And lastly, in this last case, and it's very important to recent developments on climate change and how different researchers and scientists have been voicing their concerns in public forums internationally, is also related to this really great article that I'm going to be showing you right now. So a recent study by researchers at the University of Leeds highlights how strongly the consumption from natural resources is still growing. So this problem is not just fossil fuels, it also is the overuse of other materials such as minerals or biomass that negatively impact in the environment through, for example, chemical pollution, biodiversity loss, and land use change. So this global consumption of these resources has increased dramatically, as you can see in the graph, in the last 50 years, and is now far beyond the limits of what is considered sustainable, right? So it's a really important red flag that everybody needs to know, right? So, for example, for you guys, what do you think about this graph, and what else can be, can we do to transmit how urgent this matter is? Yeah,
I think,
yeah.
For me at least, looking at this, it's a good. This shows a good graph for showing growth, but it does miss out a little bit on what, suppose a line would be for what is considered sustainable. It's missing, suppose like projections. That would be another thing, would be like consideration for like what would we consider sustainable or something like that.
Exactly. I was thinking about the exact same thing, and in the same in the same idea, it's like, what is the actually meaning in concrete terms of an increasing, in X amount of billions of tons of natural resources? So what does that mean in terms of an actual, concrete consequence, right? So even though this graph is amazing, we can keep actually adding more and more information in a more comprehensive way, right? And also in the same article, we have this also great graph that now, for example, if we also take into account that countries such as China have only very recently achieved a certain level of industrialization and prosperity, it becomes clear how unfair the distribution of resource consumption is between the global north and the less prosperous countries in the global south. So, for example, the US alone is responsible for more than a quarter of the global overshoot of the past 5 decades, and the European Union is responsible for another quarter. So here it is. The 15% of the world's population that live in high-income countries are clearly the drivers of the ecological breakdown. So, as you can see here really, really clearly in this graph, what else can we do to better visualize this worldwide unequal distribution? And what would be a better headline and caption for this graph?
I think if it was a pie chart, it might be easier to understand.
Yeah, in that sense, I disagree with you. I think that the pie chart is actually very popular, but it's not actually very useful for many types of data. Perhaps in this case, with a really consistent pattern and maybe some graphical display of like the world and the different colors indicating different countries might be a good idea. But so for example, like somebody else has some issues, so some ideas.
I had a question, and then my
Yeah.
dog started barking. This is not like an area chart, right? It's not like the United States uses 100%. Like, it's a little misleading because I feel like I want to look at it like an area chart where the percentages are like overlaid. So it makes it look like, I mean, the United States does not really use 70% to 100%,
Yeah, exactly. No, it's
right?
actually,
It's really, or
it's
what is it,
actually
65, you know?
it's how the distribution is, yeah, is being mapped on this graph itself. So for example, if you go to the link that I provided in the short document, you can actually hover with your mouse on the specific lines of that, and it will isolate the specific countries. For example, the first, the one on top on the European Union is Germany, and you can hover that and will isolate Germany, will give you specific numbers. But itself, you know, as you can see, you know, like, you know, visualizers that are playing in the major leagues, you know, in these professions, in this profession might also have, you know, some things that we can actually improve in terms of their work. So that is something that I want to put out there in the discussion. I know we're almost reaching the hour, so I'm going to be summarizing and finishing this. So the question is, what is out there? We are very fortunate. There are so many resources out there. So over the years, I have compiled a large collection of books and articles in data visualization, and I have shared with you guys in the document a comprehensive summary of all of them. So please feel free to check them out. At the same time, as I told you before, you know, it's really important to consider that a great effort of big multimedia platforms to excel and increase their visual production. And that is something that has been, you know, extremely recent. It's very rapid and rampant, the amount of content production in this sense that these, you know, big dogs in multimedia are doing. So it's something extremely important to take a look at that. So everything else, you know, all social media is actually pointing towards effective visual communication as well. And I also share with you some recent interesting examples on that shared document. Networking is actually fundamental, and you know, I had the fortune to have met more than 50 experts in data visualizations from all over the world in this you know, last year alone. And you know, just to be completely honest, I had found a great, thriving community willing to help promote content, share knowledge, and provide advice. So also feel free to reach out to these people on, you know, social media or LinkedIn or on their own websites. It's amazing how you know, strong and powerful this community is. And for example, together with Daisy Chung, as you can see here, and Dr. Heather Lynch from Stony Brook University, we have developed a webinar last November at the Alda Center. And even though thinking about a career and how to build your expertise is a highly personal journey, here are some landmarks that I gathered over the years in my own career planning journey. So first, think about your work as a unique and specialized contribution. For example, what is your brand? Think about what is your voice within all this. And it's very, very important to find your own, you know, personal voice communicating your data. Another extremely important thing is explore different resources, techniques, software, and perspective. We're also very fortunate. We have everything very accessible in terms of contacting people from all over the world, getting software, going to courses. So please, you know, take advantage of the beautiful time that we're living in terms of exploring different perspectives and tools. Another thing that I highlighted before, network with the experts, there is a, you know, strong community and very well diversified. You know, you have freelancers, you have people that are working within universities, you have people that are working in companies in different industry sectors. So it's amazing the diversity that you might find in terms of data visualizers. Another thing that everybody advised me to do and encouraged me to do is to start working on some projects and data sets, which I'm actually doing. And this capstone project is also a very important part of that. And finally, building a portfolio portraying your work is something extremely important and very useful for people to actually get to know your work. And I put some advice and some useful links on the shared document for you guys to know. To conclude, we have learned today that data visualization translates information into a visual context to make data more accessible for our brains to understand. This thriving, powerful field is radically transforming the way modern societies make decisions and interact with data. As I have shown you today, it's fundamental to learn the best practices and theory behind data visualization and apply this knowledge to specific audience-centered communication context. My objective here was to develop and launch a course in data visualization and establish a new generation of science communicators that strive to be authentic, credible, and trustworthy. As you consider your audience's needs, you might need to balance the accuracy of your graph with how it engages with your audience. One way to think of how to do this effectively is to be empathetic to your audience's needs. Take it from Alda in his book, If I Understood You, Would I Have This Look on My Face? Developing empathy, learning, recognize what other person is thinking are both essential to good communication. These are the quotes from Alda. And I sincerely believe that in a world that is nosing down onto the abyss of misinformation and hyper-concentration, we need to be less Elon Musk and more Alda. So thank you so much for all your attention and interest. And here are the multiple ways you can keep in contact with me. And I will be more than happy to answer any questions that you might have. So thank you so much.
Thank you.
Great, Nico. Do you want to take questions?
Yeah, absolutely.
Does anyone have any questions? I know Joellen came in here and she was like, I have to do something with data like very, very soon. So I don't know if this is a good time now that you've shared a lot of information, maybe to bring back up some practical concerns. I mean, this is a great opportunity for you. All of you here are connected to the Communicating Science Certificate or our other master's program. So, you know, lean on each other here. Like, what are some of the challenges? And see if you could problem solve here. I think Nico's obviously read tons and talked to tons of people, so maybe he can help you out. You were talking about SPSS.
Yeah,
Did you say SPSS?
So it's SPSS, and I'm just looking at a lot of data. And where do I start? And actually, that's probably what I need to know. Where do I even begin?
Yeah, absolutely. So one recommendation that I would give you just to start with is basically having really clear what is your audience, what is the actual message that you want to convey with that data, and to actually brainstorm. And this is a process that takes, you know, several days or hours. It all depends on your comfort with your data set and your expertise in this. It's actually, you know, brainstorming and actually sharing with people. This is actually really cool. Sharing with people, what are your ideas? Like, what if I show this way, or what versus what if I show it that way? So you actually start thinking and creating this and brainstorming some sort of alternatives in terms of how to better convey your data, you know, using different graphs, for example, or using different colors, or using different ways to actually, you know, blend numbers with figures and icons or photos. So this is the beauty of all this, because you can actually combine this with many artistic ways. So you know, like creativity is like, you know, like you're free to play to whatever you want. But as I show you, there are some really interesting theory behind that. You know, I'm specializing in neuroscience, so I'm aware of how the brain works and how the brain interprets visual information. And as a matter of fact, you know, the primate brain has evolved to be extremely visual, and we're an extreme outlier in terms of how, you know, good visual animals we are. So yeah, in that sense, visual communication is extremely important. And, you know, as the quote says, like, one picture is worth more than 1,000 words. So in that sense, I think it's very, very interesting to you know, talk to people, discuss, and just to brainstorm the best way to convey your data visually. And at the same time, as everything in life is a learning process. So yeah.
So I'll throw out a question. I'm curious about your research in evolutionary neuroscience and how you're thinking about using data visualization in your research.
Yeah, I mean that is that is a great question, and yeah, this is one of the reasons I wanted to get a to be an expert in this, because I don't know about you guys, but I'm very tired of seeing like extremely boring, unnecessary, graphs on presentations and articles, and we can do way much better than that. And I mean, the main thing is that, for example, in general, in all over the world, and have experience of working with researchers and collaborators in Europe and in South America as well, and also in the US, there is no training into how to visualize your data, and it's so important. There is a lot of training in how to write your articles, how to practice your presentation. So oral communication is covered, text communication is covered. What about visual? And as I told you, like, we are visual animals, and we need to, like, the first impression that we have for everything, like, from the dish you order at a restaurant to, like how your date is, dressed, one night, it is so important to how you, access that information. So, in that sense, I think that there is a further need on how, data visualization and training in data visualization is conveyed, both for undergrad and graduates all over the world. And that is one of the main reasons I'm very interested in that, and also combining the theory and the experimental data on neuroscience, and to transform that into an actual way to become our message, our visual message, powerful and stronger. So yeah, I see a lot of connections, and very passionate about keep connecting bridges. And at the same time, I used to work, and I keep working as a freelance graphic designer for many years, and also combining graphic design with data analysis and my own research is a really important thing to do, at least for me.
I think there's a strong intersection there of using data visualization to describe your science, but also your science kind of intersecting with the idea of visualization, or the idea of us being visual animals, which is strongly rooted in neuroscience. And it just makes me wonder if your research is involved directly in that at all, or if it's off in some other direction. So
yeah, my research is not directly involved, but many of the whole all the knowledge that I've gathered throughout the years in terms of neuroscience, I'm applying this, and there are experts that are working in this all over the world in terms of the neuroscience behind visual processing, how different colors change your mood, how there is so much data, and a lot of people working in that. I'm not working specifically in that. My work is in the evolution of the behaviors that makes humans the way we are, and I'm focusing on learning and decision making. But at the same time, I understand that for learning, for making decisions, for constructing memories, for everything that makes us human, everything needs to be visual, right? So for example, when we are thinking about an elephant, there is no other way for us to conceive in our heads what an elephant is without an image, right? It's virtually impossible, because all our memories, all our thoughts, motor commands, every single thing is actually constructed by the brain on a visual landscape. Yeah, it's very very deep when you think it that way, right? Like everything is visual, and at the same time, how we interact with information. I don't know about you guys, but I spend a lot of time in front of a screen, computer, my phone, and everything needs to be visual, right? You open Instagram and you want to post something that cool that you're doing, you need to have a good visual and something that is attractive for people to actually go there, like it, share it, and actually consume that information. So I think that there's a huge potential here, and there's a lot of potential options for a lot of people to actually specialize in visual science communication.
Yeah, thank you so much. Nico, is it okay if I share one of my favorite TED Talks with everyone? in the chat? Can I,
Yeah, absolutely.
or I can send it as a separate email. I don't, this
No,
is,
no, please go ahead.
all right, let me see if I copied it or not. Oh wait, maybe I didn't. So there's this guy, Ben Wellington, who has a website called iQuant New York. And he credits his improvisational background as a key element in how he's able to find stories in data. So Joellen, I'm not sure where you are in your process, but I love what you said, Nico, about how the visualization can actually help show you what the trends are. You know, it can kind of help the data talk, right? If you put it into different forms, that's where you might be able to see relationships or trends. Whereas if you're just looking at a column of numbers, it's very, very hard to wrap your head around that, because we have brains that you understand way better than I do, right? How that happens, right? And so it's interesting. He just kind of talks through his process and how he kind of asks questions of the data and is curious about it, and how his improv background helps with that. And I love the intersection there. So let me see if I can copy this link accurately this time. Copied. Thank you all for joining us. There's my little parting gift to you. It's a real easy watch. You could put it on in the background while you're making your dinner or something, and have fun with that.
For sharing this. So yeah, guys, thank you so much for this. You know, all this feedback, this interaction with you, for me, is extremely important. You know,
Get Fios, the 100% fiber
Oh,
optic
you started the link.
network.
It started the link.
So yeah, as I was telling you guys, like, you know, all your feedback is extremely important for me. I mean, I'm in the middle of this creative process of generating a lot of content. So, you know, just take a couple of minutes of your time to, you know, to complete that form. For me, it's going to be, you know, very interesting and very important to have your feedback. And, you know, I would love to keep this conversation going. And if you have any questions related to, hey, I have this data set, you know, what do you think, Nico, about this? Like, what would be the best way? You know, I'm literally specializing in this, so I will be more than happy to share my ideas and to brainstorm with you guys.
And then someday your case study will end up as a slide in Nico's presentation, right? Love it. Thank you all so much.
So
Thank you, Nico.
I'll comment. I really liked Brain Rules, John Medina's Brain Rules. I read it when it first came out, and really
awesome.
enjoyed that book. It's fantastic.
Yeah, it's a wonderful book. Yeah.
If anyone else has to deals with Python and is comfortable with that, I would like to share the Plotly library. If you use Python at all, Plotly is a nice library to make things very pretty.
Yeah, absolutely. I completely agree with you. I am currently training myself how to, you know, use Python. You know, in my case, I'm trained in using R, so I'm using many of the libraries that you know, R has. But at the same time, you know, Python is just a wonderful language program.
Plotly is a JavaScript framework. I think it works with R. You might want to just check that.
Yes, it does. Yeah. But yeah, you know, like Sean. Yeah. So Sean, there is you know, so many software and so many, you know, different platforms that you can use. So, you know, like, feel free to try them out. And, you know, like, Python is a really big one. It has a lot of you know, different, you know, cool things that you can do. So it is a wonderful way to start. But, you know, it's everything. When you're starting doing something, it takes a lot of time, and it's actually a learning curve to actually master this. But yeah, it's certainly worth it, and it has a lot of implications. You know, it's a really cool thing to have in your you know, tool of things that you can do.
Oh, and one thing I could ask is, could I have a copy of the slides?
Yeah, absolutely. Yeah, I will compile that and send that to you. Yeah, for sure.
Okay, thank you. Because I was making notes, but they were really interesting.
Thank you so much.
I filled your form in.